Right, this final video for chapter 6 should be pretty quick. I just want to refine the empirical rule a little bit. Recall the empirical rule was something we discussed back in chapter 3. It was based upon the standard normal curve. And it said that if you have this standard normal distribution with 0 in the middle, that if you go down 1 standard deviation and up 1 standard deviation, that should comprise about 68% of the distribution, about 68% of your observations. And then if you take it one step further, if you went up 2 and down 2, it's about 95% of your observations. And then finally, if you go up to +3 and down to -3, we said that was going to be about 99.7% of the distribution. Well, those are approximations. They're estimates. They're close, but they're not as exact as the normal model could be that we've seen so far at the end of chapter 6. For example, the area under the curve between -1 and +1 is not exactly 68%. And we could calculate this. I'm going to find this area between -1 and 1, so I could use normal CDF. Go to second bars, number 2. If I have a left bound of -1, a right bound of +1, mean of 0, and a standard deviation of 1, you'll see that we get 68.27%. Not exactly 68%. And the same thing with the 95% rule. If you go up 2 standard deviations and down 2 standard deviations, it should be about 95%. If we use the normal CDF function on the calculator, we go -2 to 2, then 0, then 1, we get 95.44%. So we're not off by that much. However, we could be more exact. And a number that we're about to spend a lot of time with in the next chapter is 1.96. If you go up 1.96 standard deviations and down 1.96 standard deviations, just a little bit short, that's going to get you closer to that 95%. Just to show you, say -1.96 as the lower bound, +1.96 as the upper bound, 0 and then 1. We get 0.95000. So we're right there at 95%. So 1.96 is actually going to get us a little bit closer to that 95% rather than that 2 and that -2. And so that's why you'll see 1.96 used a lot in the next chapter to find some 95% confidence intervals.